Hi everybody. Okay, here comes another mini lecture on statistics. This one is on something called the statistics decision tree, and I have that up here so that you guys can check it out. I've also posted this to the Canvas class so that you can download it. This piece of paper is super helpful, and at the end of this mini lecture, you're going to understand this piece of paper and be able to use it to answer questions that, believe it or not, most psychologists really can't answer. And that is simply the question of what statistical procedure should I use to analyze my data? Now, the first thing that I want to show you is that this statistics decision tree is basically branched into three areas. One is to summarize univariate data, and I showed you this last week, which was getting descriptives and frequencies. The other is exploring relationships between variables, or you can think of this as correlations. And then the third area is testing significant differences between means. So that's basically what you do with data. Statistics, I know, can be complicated and at times overwhelming, but just remember that there are only three basic things that you can do. One is to just summarize the information. The other is to see if there are relationships. And finally, the third is to see if there are significant differences. Now, if we, I'm going to skip the summarizing univariate data and descriptive statistics because we did that last week. So I'm then going to just launch into exploring relationships between variables. Now, remember when we started this course, I had you guys learn levels of measurement. And basically, I wanted you to know the difference between nominal, ordinal, and interval ratio. If you go to this thing here, it says form of data, and then you have frequencies versus measurements. What we mean by frequencies is that it's nominal information, and then number of variables, that just means number of variables. And if you only have one variable, then you end up doing something called the chi-square goodness of fit test. Let me give you an example. Let's say that you ask the question, the research question, is there a distribution of men versus women in psychology graduate school that would not happen if the main population were randomly sampled? Of course, look around you and you'll see the answer to that question is that yes, there is a significant difference between the overall population and the psychology graduate school population with regards to the distribution of gender, in that there are way more women than men in psychology graduate school. So to answer that question, you just sample your class. You'd count up how many women there are and how many men there are, and you'd have a box. Let's say you found that there are 12 women and 3 men. Well, what you'd expect to find, because men and women are 50-50 in the overall population, is 6 and 6. So the chi-square goodness of fit test just asks the question, is that significantly different from what we would expect given what's out there in the population? And the answer there would be yes. Okay, now let's say that you have two variables. Let's say that you have, for example, information about what race somebody is, which remember is nominal, and you have information about whether that person is rich or poor. So just picture a table that has, let's say, eight potential slots. Here, I'll just put it up here for you. So let's say we have African American, white, Latino, Asian, others. Okay, so and then let's say down along here we have rich, and here we have poor. And then everyone that we see will fall into one of these boxes. First we'll ask, what's your race? They tell us their race, and then we'll say, are you rich or poor? They'll tell us whether they're rich or poor, and then that would be an observation. So if we ran into a poor white person, 1. If we ran into a rich white person, 1. If we ran into a rich Latino, 1. Rich African American, 1. Poor African American, 1. Another poor white person, 2. And basically, I hope what you can see is that eventually you, in your experiment, you fill these 8 boxes up. And then the question would be, is this evenly distributed? In other words, is there no relationship between race and wealth? Or is it unevenly distributed in that you're more likely in our sample to be rich or poor based on what race you are? Okay, so that is the chi-square test for association. Moving along, and remember we're looking at relationships. A lot of times people don't think of chi-square tests as correlational tests. They are. They're not called correlations, but they're looking at relationships. So that's why they belong where they've been placed in this decision tree, which, by the way, is not I didn't make this up. It comes from this source down here. Okay, so then we get to measurements, and the level of measurement can either be ordinal or interval. So let's go first to where we have just 2 variables, and the level of measurement is ordinal. Remember that ordinal means order. So, for example, you can think of birth order, obviously, as being ordinal measurement. If you're first, second, third, fourth, fifth, or sixth, or so on, in the birth order. And you can also think of always Likert scales are ordinal. So if I ask you on a scale of 1 to 7, how much do you think psychotherapy works, where 7 is you think it works great, and 1 is you don't think it works at all, and fill in the blanks between 1 and 7. If we have those 2 pieces of information, birth order and attitude towards psychotherapy, we can see if there's a correlation between those things using this analysis, Spearman's row. Now, at this point, you might be thinking to yourself, but I don't know how to calculate Spearman's row. And this is where you're very lucky to be a student in 2014, because when I was in grad school, I had to learn how to calculate all this stuff by hand, and it is a real pain. But the good news is that all you need to really know is you need to know what statistical procedure is appropriate, and then you need to know how to ask SPSS to calculate that statistic. So in today's discussion, I'm explaining to you guys how to use this statistics decision tree. And then in the next mini lecture, I'll show you how to ask SPSS to run the analysis. And I'll also show you how to understand what the analysis eventually is when you look at the output. But for right now, you should just know that if you're trying to see if there's a correlation between 2 ordinal variables, be it birth order or Likert scale information, or the order in which you graduated in your class, I was top in my class or a third in my class or what have you, and any other ordinal information, you use the Mann-Whitney U-test. I'm sorry, you use the Spearman's row. I'm sorry, I hope that didn't confuse you guys. I was in the wrong area. But okay, so correlations between ordinal data, Spearman's row. Now we go to what you've all probably heard of many times, the Pearson's correlation. That's where you're trying to correlate two variables that are interval data. Let's take, for example, age and income. Both of those are interval data. How old are you and how much money do you make per year? And if you wanted to see if there's a relationship between those two variables, you would run a Pearson correlation. And I just want you to kind of mull over in your own mind what would be another example of two pieces of interval ratio data that you could use a Pearson correlation to analyze. You should be able to come up with these relatively easily. I'm going to put a little quiz on here just to make sure that you guys are able to do this. Okay, so after Pearson's correlation, then there's multiple regression. Multiple regression is when you're trying to use two or more predictors to predict one dependent variable. Let's say that income is our dependent variable. I want to predict your income. I don't know your income, but I do know some other information. Let's say that I know your IQ, I know the exact value of your childhood home, and I know how many years of education you had. Now, if I put all that information into a regression equation, then I should be able to predict your income. And so these are, multiple regressions are, to me, they're fun because you can use them to predict stuff that you wouldn't ordinarily know about somebody. But of course, in order to build a regression equation, you first have to gather all the data. So for the example that I gave, you get a sample of people, you'd ask their IQ, the value of their childhood home, their years of education, and their income. And you'd put the first three variables into the predictor side and their income into the dependent variable side, and you just see what the correlation was. The higher the correlation when you do a multiple regression, the more accurate your prediction equation will be. So, for example, if I was trying to predict your income, but my other variables were your shoe size and the number of childhood friends you had, then I could build a multiple regression based on that information, but the relationship between those variables and income is too small, so I'll probably get an insignificant multiple R. And so that's why if you're doing research that involves multiple regression, you would always want to have some theoretical basis for putting your predictor variables into the equation. Now, we may get into this later, and it's a little bit of an advanced idea, but just so you know, when you do a multiple regression, there's something called stepwise regression, which will only include variables that significantly help you to predict the dependent variable. And if you have a variable in there that doesn't really add to the predictive power, the equation will actually kick it out, and you'll build a multiple regression equation without that variable being included. And the reason is it just doesn't significantly add to your predictive power. Okay, so that is, in a very quick nutshell, the exploring relationships between variables side of the house. And I hope you followed that okay. Of course, you should do your reading about correlations and about ANOVA and t-tests and all these things in your textbook. But I actually think that just through listening to this mini lecture and doing the quiz afterwards, I really do feel that you'll have a sense of, okay, you can give me a research question, and I'll look through this decision tree and I'll tell you what statistical procedure to follow to answer the question. Sorry, that's my cell phone. Just a minute. Okay. All right, so now let's move to testing significance of differences. And the first question is, how many groups do you have? Let's say that you have just one group. Let's say that we're just looking at psychology graduate students. And we are going to compare our sample to a specified value. Well, that would be a one-sample t-test. Let me give you guys an example. You probably know that the MMPI-2 has, as its scaled score, a mean would be 50 on the scales and a standard deviation of 10. So let's say that I give a class of psychology graduate students the MMPI-2 and I gather information on their scores on the depression scale. And let's say that they have a mean of 58 on scale 2. And my question would be, is our sample of graduate students significantly different than the normal population that was observed to calculate the t-scores for the MMPI-2? So what I would do is I would do a one-sample t-test. I would take all the MMPI-2 scores, put them into SPSS, and then I'd do a one-sample t-test where I would specify that the mean of the population is 50 and the standard deviation is 10. And then ask SPSS to do a one-sample t-test, and I'd see are psychology graduate students significantly more depressed than the normative sample. Okay, by the way, I'm sure you realize we could do the same thing for IQ scores. We could gather IQ information. The normative sample mean is 100 with a standard deviation of 15. So you'd put that information in and you'd compare your sample that you obtain of IQ scores from graduate students and see if they're significantly different. Okay, let's say you have two groups. Now you're going to be comparing two groups. The groups could either be independent samples, like men versus women, or, well, there's so many possibilities. But anyway, people who can't be in both groups, or they can be related samples. For related samples, you should be thinking people who are measured twice. For example, pre and post testing after someone takes a class to see if they've learned anything in the class. Okay, so let's go through this leg over here. Two independent samples where you have ordinal data. Let me give you an example. Let's say you have men versus women, and you ask them on a Likert scale, how attractive are you? So everyone gets asked a question on a scale of 1 to 7, how attractive are you? 7 is very attractive and 1 is unattractive. And you want to compare, do men and women have significantly different attitudes towards their own attractiveness? That would end up being a Mann-Whitney-U test. Now let's say that you got interval data. And an example of that would be, let's say, psychologists versus MFTs. So remember, those are independent samples. Either you're a psychologist or you're an MFT. Although I know some of you are thinking, well, I'm an MFT and I'm also going to be a psychologist, but just for the sake of sanity, let's just say that we have two different groups here, people who practice under one license versus the other. And let's say that the form of data is interval. Let's say that the data is income. So psychologists versus MFTs on income. And then you would do what we call an independent samples t-test. Okay, now let's move over to related samples and ordinal data. And I'll give you guys an example for the Wilcoxon matched pairs test. Let's say that you want to do before and after on attitude towards psychotherapy. So you take some people and you ask them, does therapy work? Yes, or to what extent does therapy work? And you do a 1 to 5 Likert scale, very effective on one end, ineffective on the other, and neutral in the middle, and so on. Okay, so let's say that you're comparing people before you give them that as a pretest, then you give them 10 sessions of psychotherapy, and then you ask them again whether or not what their attitude is towards psychotherapy, and you're just finding out, is there a significant difference between pre and post therapy on attitude towards psychotherapy. Okay, and now let's go over to the interval side where we do a paired samples t-test. Let's say that you have a hospital unit which treats eating disorders, and you decide to implement a new kind of treatment for eating disorders. Let's say you implement, let's just say you try EMDR for people who have eating disorders. And you ask people, how many previous hospitalizations have you had? And then you put them in this condition where they get EMDR, and then you follow them for 10 years, and you see in the 10-year period before the hospitalization with the EMDR, how many hospitalizations did they have? And in the 10-year interval after the EMDR, how many hospitalizations did they have? So do you guys see how that's paired samples, because it's the same group being observed twice, and it's interval data because the data is how many hospitalizations have you had between 0, let's say, and 100. Okay, so I hope that's clear. Now we're moving to the next leg of this, the multiple groups, independent samples, and we'll go to one independent variable, which would be a one-way ANOVA. Let's say that, remember the example I gave you guys a while ago, the chi-square test for association, race versus rich or poor? Now remember, those were both nominal. Rich or poor, you're either one or the other, and race. Okay, now let's say that we had a similar experiment where we asked two pieces of information. One is, what is your race? But the other is, what is your income? Not are you rich or poor, but what is your actual income? Now we have interval ratio data, and we can find out if there's a significant difference between the races on income. Now let's say that we have multiple independent variables. Oh, by the way, in that example I just gave you, the independent variable is the variable that separates the groups. That would be race. The dependent variable is the variable that you're observing. That would be income. Over here you have multiple independent variables. Let's say that we just did race and gender on income. So now what we would have is, you can think of it as two basically rows and columns now. Instead of just one row, we also have for each race 2 columns, one for men and one for women. And in each one of those cells, we're going to have the average income. So average income for an African American man, average income for an African American woman, average income for a white man, average income for a white woman, and so on. And that will then lead us to be able to further understand, for example, do we have a situation where gender makes a significant difference in income, or race makes a significant difference in income, or do they both make a significant difference in income? Or could it be that when they're both looked at together, there's a significant difference, but only if you look at them together, such that, for example, white women make significantly less money than white men, but Asian women make significantly more money than Asian men, or something like that. That would be called an interaction. And if I just lost you there when I talked about the interaction, don't worry about that quite yet. We will get there. But for today, I just want you to understand the situation in which you would choose to do a multifactorial ANOVA. It would be when you have more than one independent variable and you have interval ratio data. Okay, and then finally, the last one on here is related samples, repeated measures ANOVA. So let's just say that you had an intervention on eating disorder intervention, and let's say your question was, in the last 6 weeks, how many times did you binge eat? Then you do the intervention, and a week later you say, in the last week, how many times did you binge eat? And then 6 months later, you ask that same group the same question. Now what you're doing is you're looking at the same group over repeated measures, and you're asking the question, is there a significant change among this group over time? So, okay, that's it. That's the whole statistics decision tree. When you are given a example of a type of research question, you should, armed with this information, be able to answer the statistical analysis that you'll use just by following this tree. All right, let me just make one up off the top of my head, okay? Let's say that I asked you to analyze whether people in California are happier than people in New York, and the happiness measure would be the number of times they smile per minute. So what you would do is you just interview them for 1 minute, or just, no, you'd film them for 1 minute, and you'd count the number of smiles. So right now what you should be thinking is, okay, we are testing significance of differences. We have two groups, New Yorkers and Californians. They're independent, and the data is interval. It's number of smiles in 1 minute. So we would use an independent samples t-test. Easy, right? Okay, let me think of another one off the top of my head, okay? Let's see here. Let's say we wanted to know if there are okay, we have three campuses in Southern California for the Chicago school. Let's say we wanted to know if the students were evenly distributed across all 3 campuses. So we'd count the number of students in LA, the number of students in Irvine, and the number of students in Westwood, and see if they were evenly distributed. What would that be? Well, that would be chi-square goodness of fit test. We'd have Westwood, Irvine, LA, and let's say that we have a total of 300 students. We'd expect there to be 100 in each campus if they were evenly distributed. That's why we would do that test. Okay, my guess is that at this point you guys feel like you're understanding this. I'd like you to print out, or, well, if you want to save some paper, you don't have to print it out, but just access this decision tree through your Canvas course, and then when you're ready, take the quiz that I'm going to put up, which is just going to ask you basically some research questions, and it's your job to figure out what statistical analysis to use. Okay, and of course, as always, call me if you have any questions or anything that you want to discuss.